Okay, so refraction is studied under two headings. One is called as refraction at plane surface. Another one is called as refraction at spherical surface. Okay, so in this also we have many topics. Refraction at plane surface. One will study first glass slabs. Okay, and then afterwards we'll have real depth, upper end depth, and many models of problems in that. Okay, and then afterwards we have specifically prism. Okay, a separate topic. Okay, and then again we have refraction at spherical surface, that's called lens, which is very important. Okay, so there we'll study again whatever we studied in mirrors, everything, properties of image. Then Gaurina, switch off your video. So properties of image, then magnification, then problems on that. Okay, and then cutting of lenses. Okay, then silvering of lens, combination of lenses. So many topics are there, and this is what very important. And if at all problem comes from optics, means it will come from this spherical refraction at spherical lens only. Okay. So now what I'll do is actually I should start refraction at plane surface, but instead I'll start refraction at spherical surface little bit, and then I'll go to the refraction at plane surface. Okay. The reason for doing that is when you try to understand this one, this becomes very easy, because this plane surface is nothing but a part of spherical surface, correct or not? Suppose let us say this is a spherical surface, okay, whose radius of curvature is this one. Okay, this is called as radius of curvature. Now this plane surface, as the radius of curvature increases, this plane surface, what will happen? Sorry, spherical surface will become what? Plane surface. Now see here, this radius of curvature is more, correct or not? So like this, when this becomes, when the radius becomes infinity, that is called as plane surface. When the radius becomes infinity, that's called as plane surface. Okay. So therefore, first I'll start with the refraction at spherical surface little bit, and then I'll go to refraction at plane surface. Okay. So today I'm going to start with the refraction at spherical surface. Refraction at spherical surface. And by studying like this, it becomes very easy. The plane surface will be very easy. Okay, because you already studied the spherical surface. So just by replacing r with infinity, you will get everything here. Okay, so therefore studying in this way is very easy. So refraction at spherical surface. Refraction at spherical surface. So refraction at spherical surface, we are going to see, is very easy. Okay, this topic itself is easy, and by studying this first and then afterwards studying that one is much more easy. Okay, so refraction at spherical surface. Okay, so suppose let us say there is a spherical surface separating two different media. Suppose let us say this is a spherical surface separating two different media. Okay, means suppose let us say this is one medium, let us say mu1, and this is another medium. Okay, suppose let us say this is air and this is some like glass. Okay, that means this is like a glass, this is a part of a glass sphere. Assume that it is a part of what? Glass sphere. Maybe it's like glass sphere. Okay, so this is like air and glass. Okay, one is mu1, another one is what? Mu2. Okay, so now when you place an object here, okay, here. Okay. So first what we'll do, we'll draw incident rays, correct or not? So incident rays will draw. Okay. So this is one incident ray and this is another incident ray. Okay. this is called as incident ray. These two rays are called as incident rays. Okay. Now this is what you call, this is like pole. Okay. So now what will happen is it will travel as it is. That means here angle of refraction will be what? 0. Angle of refraction will be 0. So therefore it will go like this only. Now this ray is incident at here. This ray is incident at here. Now we have to draw a normal. Okay. Now we have to draw a normal like this. Okay. This is called as center of curvature. Okay. Now this angle is called as angle of incidence. This angle is called as angle of incidence. So now whenever a light ray is going from one medium to another medium, it will bend either towards the normal or away from the normal. Okay. So now at this point, the light ray now will not go straight. It will bend like this, either towards the normal or away from the normal like this. It will not go straight. Okay. It will not go straight. Either it will bend towards the normal or away from the normal. Towards the normal means angle will be less. See here. And away from the normal means angle will be more. So now let us say it is going towards the normal. Okay. So that means now here it is. Now this ray also will meet here. This ray. So now the intersection of these two rays is called as what? Image. Refracted rays. Okay. Is called as image. And these two rays are actually meeting. So it's called as real image. And this is called as real objects. Okay. So anyway, this is called incident ray. This is called as refracted ray. This is called as angle of incidence. This is called as angle of refraction. Okay. And the ratio of these two angles is called as refractive index, which is called as Snell's law. Okay. Afterwards, I'll tell. Right now, Snell's law is not required. Just remember that right now, what I'm teaching you is how the refraction will happen at spherical surface. This is a spherical surface which is separating two different media. Is separating two different media, mu1 and mu2. And suppose let us say object is in medium 1. Now from object, incident rays will fall on the surface and then they'll get refracted and then they'll meet at this point. This is called as image points, okay, which is present in another medium, mu2. Okay. Now we know that this is called as we know that this is called as object distance. Okay, just like in mirrors. Here also this is considered as like a pole. Okay, this is considered like a pole, and this distance is called as what? Object distance. This is called as object distance. Okay, and this is called as what? Image distance. This is called as what? From here to here is called as image distance. This is called as image distance. So now, and this distance is called as radius of curvature. This is very, very important. This distance is called as radius of curvature. From pole to C is called as what? Radius of curvature. Okay. So totally we have these terms. One is called as object distance. Another one is called as image distance. Another one is called as radius of curvature. Another one is called as mu1. Another one is called as mu2. Okay. These terms we have. Now there is one formula relating these terms. U, V, mu1, R, mu1 and mu2. U is called object distance, V is called image distance, R is called as radius of curvature, measured from pole to the center of curvature. Okay? And mu1 is the refractive index of first medium, mu2 is the refractive index of second medium. Okay? So now here also the way we calculate this image distance, they'll give these quantities. U they'll give, R they'll give, mu1 they'll give, mu2 they'll give. They'll ask us to find out V. So we calculate V using this formula. Okay, just like we have mirror formula. Na? In case of mirrors, 1 by F is equal to 1 by U plus 1 by V. In a similar way, we also have a formula for refraction at spherical surface. We have a formula of refraction at spherical surface. That formula is very, very important. Everybody should by heart this one. Okay, that is given by mu2 by V. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. This is a very, very important formula. Right now, derivation is not required. Just remember this formula. Okay. So mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Okay. So what is meant where what is mu1? Remember this as refractive index of that medium in which incident ray is present. Refractive index of that medium in which incident ray is present. Like this, you can remember. Incident ray is present, or in other words, we can also write as refractive index of that medium in which object is present, because incident ray and object are related. Okay. Next, mu2 is nothing but refractive index of that medium. In which refracted ray is present. Okay, and remaining things we already know. One is called as U, which is called as object distance, which is similar to spherical mirrors, where it is measured from the pole to the object, okay, including sign convention also. And V is called as
Sir?
what?
Sir, is this the lens maker's formula?
No. Lens maker's formula is different. 1 by F is equal to mu2 with
1 by V minus 1 by V.
1 by R1 minus 1 by R2. That is different. Okay. So this is refraction at spherical surface. Okay. This is refraction at spherical surface. So U equal to object distance, V equal to image distance, and R is nothing but called as radius of curvature. Radius of curvature of spherical surface. Radius of curvature of spherical surface. Okay. So this is very, very important. Okay. So please note down this formula, very important. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Now, if this spherical surface happens to be plane surface, then what is R? Just now I told. If this spherical surface happens to be plane surface, then what will be the value of R?
Infinity.
Infinity. So 1 by infinity is 0. So this formula mu2 by V minus mu1 by U equal to 0 is nothing but refraction at plane surface. That's all. Okay. If you understood this only this formula, then refraction for both surfaces is covered, spherical and plane. Okay. In fact, if you understood this one, you understood refraction. Okay. But here the most important thing is you have to substitute these quantities with sign convention. This V, this U, this R. These three quantities you should substitute with sign convention, which is similar to the spherical mirrors which we have studied. Okay, everything is same. Okay, first one is the incident rays are traveling from left to right. Next one is all distances are measured from pole. Next one is any distance measured in the direction of incident ray is taken as positive. Any distance measured opposite to the direction of incident ray is taken as negative. That's all. Okay, and above the principal axis is taken positive, below the principal axis is taken as negative. So please write down, this is a very, very fundamental formula, fundamental formula. This one. Okay, I'm repeating many times to emphasize the importance of that one. Okay, so now let's write down some important points on this. Okay, so first point is, okay, all quantities U, V and R should be substituted with the sign. Should be substituted with the sign. Okay. Next. Now here, just like in spherical mirrors, there is a formula for magnification there. Correct or not? There we have mirror formula. First one is mirror formula, 1 by F is equal to 1 by U plus 1 by V. Using this, we'll calculate V. And then if you are asked to calculate magnification, then height of the image by height of the object is equal to minus V by U. Now here also, we have formula for calculating the image distance as this one. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. And second one, magnification formula here is magnification M is equal to, okay, mu1 by here also it is V by U, okay, V by U, but in addition you will have mu1 and mu2. Okay, this is the formula for magnification. Please remember, this is a very, very important formula. Okay, magnification is equal to mu1. First remember it as V by U plus V by U, and just before that coefficient you write as mu1 by mu2. That's all. Okay, mu1 by mu2. And next, third point. For a plane surface, what is the value of R? For a plane surface, the value of R is equal to what? Infinity. Correct or not? Just now I explained. So therefore, for a plane surface, the formula will become mu2 by V minus mu1 by U is equal to 1 by infinity. 1 by infinity, basically mu2 minus mu1 by infinity. So this part will be 0. So therefore, this implies mu2 by V is equal to mu1 by U. That's all. See, very simple. For plane surface, this is the formula. Okay. And then last point, fourth point. If an object or image, if an object or image if an object or image is on the boundary itself, boundary means, suppose let us say like this, suppose this is a spherical surface separating two different media, mu1 and mu2. Suppose object is at here only, at the boundary, or image is at the boundary itself, is on the boundary, then refraction will not happen, on that boundary. Okay, this is also very important point which we'll use in solving problems. Like solving problem, this point is very important. Okay. Okay, so I hope you understood this one. So basically these two things are there. In this chapter, we are going to study this one, V by U into mu1 by mu2. In this chapter, we are going to use these two only, that's all. As I told you before also, ray optics means only two things. One is solving, another is drawing ray diagram. Solving means these two. With these two formulas you will solve, then you will draw the ray diagram, that's all. And in this optics, only one standard question. Find the image, that's all. Find the location of the image like that. Okay. Let us take one problem. Find the image of point, find the question. Okay. Find the image of point. Find the image of point object O. So in this entire ray optics, you'll have this one only. Find the image, find the position, find the nature. That's all. Okay. In optics, finding out the image. In current electricity, finding out voltage and currents. That's all. These are the two standard questions. Okay. Our next chapter is current electricity. Okay. So now let us see. So this is a spherical surface separating two different media. Okay, this is 1, this is 4 by 3. Okay, and there is an object which is at a distance of 20 centimeters. An object is at a distance of 20 centimeters. Okay, and the radius of curvature is given as 40 centimeters. Radius of curvature is given as 40 centimeters. Find the image of the point object O. So always remember, the way to solve this one is just using that formula. Okay. So first write down given values. That's all. Given mu1. What is mu1? Mu1 is the refractive index of that medium in which object is present. So here it is 1. Okay. And mu2. Mu2 is what now this ray will get refracted and then it will fall on this medium. Correct or not? So therefore mu2 is equal to 4 by 3. And what is object distance here? This is called as pole. So you are going left side. So that is minus 20 centimeters. And now we are asked to find out what is V and what is R. Is it plus 40 or minus 40? That depends on this. Now you see, this is a part of this sphere. No? The spherical surface is a part of this white colored dotted sphere. Correct or not? Whose center will be here? So this is called center of curvature. This is called pole. Okay. So now from here to this distance is called as R. But arrow should be placed like this or like this. Which side we should place arrow? Arrow should be placed in such a way that according to sign convention.
To the right, sir.
Correct. Because all distances are measured from pole. So you should start from here and go towards pole. So now this arrow is in the direction of incident rays. Our incident rays are always traveling from left to right. So therefore it is plus 40 centimeters. So now we have the formula. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. That's all. Okay. So what is mu2? 4 by 3 by V minus what is mu1? 1 by U minus 20 is equal to mu2 4 by 3 minus 1 by R. R is 40. So therefore 4 by 3V, this is plus 20. It will go that side. 4 by 3, that means 4 minus 3, 1. 1 by how much? 120, correct? And this is plus minus 1 by 20. Okay. So therefore here If you calculate this one, you'll get as answer as B is equal to minus 32 centimeters. Okay, minus 32 means which side? Minus 32 means
Sir, towards the left, sir.
towards left.
Left, sir.
Very good. Towards left. See here. Somewhere around here, 32. So that means now our image is here. Please see here. Now our image is here. Now, as I told you, the ray optics has two things. One is solving, another one is what? Drawing. Now you have to draw the ray diagram according to the solving parts. Okay. So now let us see how I'm drawing. Okay, this is also very important to know. Okay. So now one ray is always taken as like this, another ray is incident like here. Okay, at this point. Okay. So these are the two incident rays. Okay. Now at this point, this is called as the normal passing through center of curvature. Now see here. Now this ray, okay, either it can be towards the normal, or it can go straight, or it can get diverged. Correct or not? Okay. So now see here, how to draw this ray depends on this image. Okay. Right now image is here. So what you have to do is, now you have to draw a line from here to here like this. Okay. Now our ray is like this. See here. Okay. This is called as refracted ray. This is called as refracted ray. Okay. So please see here, mu2 is the medium in which refracted ray is present. Okay. So therefore, now this is called, now image is here. Okay. Why? Because the ray is getting diverged. Okay. It's going from rarer medium to denser medium. So it will go away from the medium. Okay. Suppose if this ray were to go like this, then it will meet here, then you'll get image here. Okay. But since the ray is getting diverged here, and how to know whether the ray is diverged or not? By solving only. That's why first step is very, very important. First step is very, very important. Okay. So first you have to solve, then only you'll know whether the ray is getting diverged or converged, or it is going straight without getting without bending. Okay. So this is very, very important. So solving and drawing, solving, drawing, solving, drawing. That's all. Okay. Now suppose, let us say, if you have one more surface here, now what will happen? Tell me. Suppose let's say this one more surface is there, which is separating now another medium. Correct or not? Now this surface, this is, let's say, surface A. This is surface B. Now this surface B is separating 4/3 water and air. So now this ray is going, now this is a reflected ray for this surface, becomes what? Becomes
Incident ray.
correct. Incident ray for this second surface B. Now this surface will see this ray coming from where? Coming from I, correct or not? So therefore, now for this surface, this is called as object distance. This is called as object distance. What is object distance now for this surface? Here up to here, it is anyway 32 centimeters from here, correct or not? And from here to here, this is nothing but radius of curvature is what? 40 plus 40, 80. So 80 plus 32, that's all. 80 plus 32 is what? 1/4. So again, the ray will get refracted, correct or not? The ray will get refracted or not again? Okay. So here the ray will get refracted, either like this or like this or like this, we don't know. Okay. So that depends on the calculation. So therefore, again, you have to calculate. Again, do the same procedure, but only thing is what? Now for surface B. Okay. For surface B, this is what? For surface A. Okay. Now the same thing will be. Okay. So now for surface A, again mu1 is equal to 4/3. Why mu1 is 4/3? Because for this surface B, this is the incident ray, and the refractive index of the medium in which incident ray is present is 4/3. Now what is mu2? Outside air. And what is U? It is equal to minus 112 centimeter. And V, we don't know. Radius of curvature. Now what is the radius of curvature? Now tell me. Now this is our surface. That means this is our pole. Now tell me, what is the radius of curvature? What is the radius of curvature now?
Minus 40, sir.
Correct. Minus 40. Why? Because you have to measure from here to here like this. So therefore minus 40. That's all. Now again apply the formula mu2 by v minus mu1 by u is equal to what? Mu2 minus mu1 by r. If you solve this one, you will get v. Suppose v you got at plus, then this ray will get, then what will happen is this ray will get converged this side. Plus means this side. No? Suppose you get minus, then it will become somewhere. Depends on this one, either like this or like this or like this. Okay. If it is plus means it will get converged. If it is minus means maybe somewhere like this, so that it will get extended here. Minus means like this. Are you able to understand? Easy or difficult?
Easy, sir.
Shall I give one problem? Homework. Okay, take down this homework problem. Find the image and its height. Find the image and its height. Height means magnification. Okay. So this is a spherical surface separating media. This side is 1, this side is 4/3, means water. Okay. Now radius of curvature is given as 20 centimeters. Okay. And object is height is 1 centimeters at a distance of 40 centimeters. Okay. So this one, another one is two surfaces problem. I'll give two surfaces problem. Okay. Find the final position of the image. Find the final position of the image. Okay. There is a sphere. Okay. There is a sphere like this. This is a sphere. Please remember, this is a sphere. Okay, glass sphere. This is a glass sphere. This is a glass sphere. So since it is made of glass, so its refractive index is how much? 3/2. Okay, sometimes they'll give, sometimes they won't give. Okay, but you should by heart. Okay. Now there is an object here. Okay, there is an object here exactly on the boundary. Okay, exactly on the boundary. Okay. Now this side is our eye. We are seeing this one. We are seeing through this glass sphere this object which is just exactly on the boundary. Okay. So what is the final position of the image? Where will be the image? Okay. So that means always remember, first the incident rays will always start from the object. So therefore draw. So now since the object is on this boundary itself, we should not take refraction at here, according to that note which I told. Okay. So you should not take the refraction at this. Suppose let's say this is surface A, this is surface B. Okay. So at this surface A, there is no refraction. No refraction is there. No refraction. Okay. So that means now what? The incident rays will be going from here, from like this only. Okay. Like this one ray. I'll take another color. So this is one ray and this is another ray. Now these two are the incident rays. Now they are falling on this surface. So now apply formula for here. Here at this point you apply the formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. That's all. Okay, will you able to do homework? Simple problem. Okay. Tomorrow we are going to see applications of this one. Okay. That's all for today's class. And today afternoon, I may take doubt session. Anyway, today afternoon, any class do you have at 3 o'clock?
No, sir.
No. Okay. Okay. Actually, your chemistry class will finish by 3. Huh?
Yes, sir.
Okay. Then I'll take it 3:15. Then I'll take it 3:15. Okay. So those who are interested or those who want their doubts to get clarified, they can join at 3:15, 3:15, maybe half an hour or 45 minutes I'll take. Okay, 3:15. And yesterday I sent another work session. I think work session number 9 or 10. Okay, so please solve those work sessions, and I'll give one more work session maybe on spherical mirrors. Okay, and then afterwards, after completing half or something of refraction at plane surface, I'll give another work session. Okay, but I'll give work sessions both parallelly. That means first year and second year. So now it's time for you to do both the years, first year and second year. Okay, any doubts? Any doubts? Okay, then. Okay, thank you all very much. Okay,
Thank you,
we'll
sir.
meet,
Thank you, sir.
for doubts, please join at 3:15 today.
Thank you, sir.
Thank you.